And I need to change the speaker view and put me up there. All right. So hopefully it's live now. And we are going to look at problem 1.14 from the workbook. Here it is again. And so again, if you want to take off and just do the live stream, that's cool. If you want to work on your own, that's cool. The only time you really have to be here is for tests and for group activities and things like that. Okay, so I'm just writing down the same information you are probably writing down. Getting it on my paper is the first step. 10 to the negative 1. And I'll share my whiteboard when I'm done, okay? And then I'm just checking, what are we supposed to do? That's always good. Compute this, answer in engineering notation with appropriate prefixes, correctly round. Okay. So I'm going to show you what that means to me. And if this is too much for you, I will give you some slower paced videos after the fact. Okay. I have a whole bunch where I did these at much slower speed, showing more steps. That said, here's what we've got. We know the equation is delta x is 1/2 a sub x t squared. If you've had a physics class, which all of you have, or you're supposed to have had, you know this equation. So all we're trying to do is plug in these numbers. If we can't do this right, how are you going to do actual physics? It's a good warm-up. So you could race ahead, check the answer and the solutions. If you're still waiting for me, do another problem. Okay, so we've got 1/2 a sub x is negative 1.23 times 10 to the negative 1. And now I'm going to stick in the units. Very often in lab, the units are written up above. That's meters per second squared. I'll get to the chat there in just a second. You could chat or ask questions at any time. Yep. Okay. And then t squared.
Professor Jorside?
Yep. Go for it.
The ones in the parentheses for the ax and the v0x and the t, that's just like the units, right?
These are the units up here. Absolutely. So okay. This is a common way in a lab how you mark the units. Because imagine if you had a whole bunch of these.
Yeah.
Right. You only want to write the units one time in there, and then these are just numbers so that Excel can actually compute them. Good comment. So those are just the units up there.
Do we need to write that graph table, or is it just to help us?
I'm just doing it because I hate looking at multiple pages at once. So yeah, you don't need to write that table out, but if it helps you, that's great. I like to have all the information on one sheet of paper. Generally speaking, you're not going to have a problem that looks like this all the time. Most of them, it'll be in a word problem, and then it makes sense to make your own table to organize your thoughts. Did that address that question?
Yeah.
Right on. Yeah. Organize it in some way. And basically, you're going to find your own style. And if my style works for you, great. If mine doesn't, find something comparable that works for you. Sweating in this room here. Now, I'm running out of room. Sorry, my whiteboard sucks. So I'm just going to kind of sneak it down there. Okay. Now, you're not dumb. You could punch stuff into a calculator. I know that. Just trust me. There's a reason to go through this early because I'm telling you what my expectations are for your calculator work. I know you could punch this in, but let's look. Did I forget the squared right here, I think? Yeah, I did. Okay. So when I do this, let's punch in the numbers for the first term. You could use pretty much any calculator you want. By the way, if you're an engineer, you're going to have to learn how to use a scientific calculator someday. If you want to start learning it this semester, great. If not, do it next semester. In face-to-face classes, I require scientific calculators. All right. Okay, so 0.5 times negative 1.23 times, whoops. Oh, this is something I wanted to show you. On a lot of calculators, there's an EE button. Get used to using it correctly. So you hit EE, that means times 10 to the. It does not mean exponent, it means times 10 to the. So then I type in, what was it, -1? So that's how I would write that. Times 0.0987x squared. Oh, and I'm in a different mode. Let me get out of that. So I got that. Okay. I'm just going to write that down so I don't get lost. What are the units for this first term? Remember, Mark, you can always check the answer in the solutions, and technically that's wrong. Okay. You could if you get this done faster than me, you could read the solutions and find out. Okay, what the units are going to be meters per second squared times seconds squared, which are meters. Okay, plus doing this one.
So do you want us to like do them separately instead of plugging in everything at the same time?
I'll show you why in a sec. You
Okay.
could plunge it all in and get the number, but this problem asked us to round correctly. I'll show you why.
Okay.
Just
For the sig figs, okay.
Sig fig math is going to screw this up. So I'll show
Oh.
you why in just a second.
Because it is addition and multiplication.
Yeah. So you guys are saying great stuff. This is awesome. You guys are staying motivated, engaged. So that's cool. Anything you can do to not be bored and fall asleep, do it. Okay. And I hope you agree this one's also going to be meters, right? Now I want to talk about sig figs. Look at these numbers up top. How many sig figs does this number have?
3.
This one?
3.
And this one?
3.
3.
3. These are leading zeros, never significant. So these all have 3 sig figs. I indicate the sig figs with a little underbar. You're going to see this in my notes. Okay, so I'm trying to teach you how I keep track of sig figs. I actually learned this from a chemist. I know physicists and chemists don't get along. I love to make fun of chemists as much as possible, but they actually know something. So we better actually listen to them once in a while. And this is definitely one of those times. All right. And if you're a chemistry major worried that I'm going to hate you because you're a chemistry major, I'm just teasing and just having fun. If I can't make fun of chemists, I don't know what I would do with my time. I'd have to actually do a good job teaching or something, and I can't do that. Okay, so now, all right, let's focus on this. That was an attempt at humor. This is 3 sig figs. This is 3 sig figs. When we multiply them, how many sig figs should I get?
3.
3. Nothing crazy. All right. Now remember, these are leading zeros, not significant, and then 1, 2, 3. How about this one? 3 and 3. This one should have 3. It's right there. Add them together in your calculator and you get, okay, so I'm just going to go that plus what was up there. So learning how to use your calculator could save you some time. And so it was and then I need the units, right? We're going to keep the units. Now let's check the sig figs. When you add this number to that number, they each have 3 sig figs. How many sig figs do you think we should have down here?
3.
2.
2.
Wait, I can't see.
Yeah. Oh, sorry. When you add or subtract, it's not the number of sig figs, it's the column. And that's why I wrote all this crap out. We can
Could the
see
new
that.
number not be negative?
What's that? Oh, yes, it should be negative too. Thank you. I forgot to write that down. You are correct. Good job. All right. Nice. So yes, absolutely. It should be negative. So I was too focused on sig figs. Now look at this one. This is in the 1, 2, 3, 4, 5, 6 decimal place. This is in the 1, 2, 3, 4, 5, 6 decimal place. Shouldn't this one also be in the 6 decimal place? I'm having trouble. 1, 2, 3, 4, 5, 6. And notice that's the rounding column. I do this to students all the time on exams just to see if they remember sig figs. All right, so to round this answer, we would actually round it to 2 digits, not 3. And so I just wanted to watch out for that. When you add or subtract, the number of sig figs could change. I like to bring up this example. What if you had 90 marbles, or let's say 91 marbles plus 11 marbles? You'd know you'd have, what is that? 102 marbles with 3 sig figs. The two initial numbers each had 2 sig figs. It's okay to have the number of sig figs change when you add. When you add numbers, usually the sig figs could increase or stay the same. When you subtract, you might lose a sig fig. So just watch out for that. Okay, so did we answer this question correctly?
Not yet.
Let's go back and see what we're supposed to do. What did we not do?
Engineering notation.
Engineering notation with prefix. So this is not valid. Okay, so what we can do here, whoops, let me stop the screen share. Don't make this hard on yourself. If you got a calculator, it's really easy. So you can go, sorry, I'll hold still for a sec. If you hit the mode button right here, mode, you can go down. Sorry, it's hard for me to do this on Zoom. Whoops, wrong way. I could go over here to engineering mode and hit enter. And then I can quit. And then I could just hit answer. So I just hit answer and enter. And it gives it to me in engineering mode. The other way you could do it is by counting left and right. So if you're trying to do engineering mode, you could just say, well, go over in 3s. 1, 2, 3. I'm not there. 1, 2, 3. There we go, right there. So notice this is 21.7 times 10 to the minus 6th meters. And then I'm going to round it in the second column. Okay, and let me get the chat question. Ha! Yeah, Jacob, we did this exact thing in class last semester, but you know how it is. It's hard when this stuff, we do 100 things in one day and you miss that one, right?
Professor,
yeah.
So when I did this equation, I got the numbers that you did.
Right.
Before I added the 2 meters together,
Mm-hmm.
2 different lengths together, I actually had to cut it off at the sig fig. Like, is that right, or should I not be doing that?
You should never round too early. I'll show you why in just a second after I finish this. We're almost done, right? So yeah, good question. That's called intermediate rounding. I'm going to show you why you should never do that.
Then how many places should I go after the sig fig?
At least 1.
At least 1, okay.
But 2 is overkill. Okay, so let's finish this problem. So right here, this prefix is associated with micro. So it's okay if you don't know some of this stuff, but you got to let me know. In theory, this is supposedly you know this stuff already, but everybody has different knowledge coming in. It's okay if you don't. I'll give you some training videos that you could use outside of class, or I'll show you some problems, okay? Let me get this done. So this is 22. If you don't know how to write the mu symbol for micro, just draw a letter U and then add another line. That's micrometers.
Also, isn't that supposed to be a negative?
Oh, yeah, you're right. Thanks. So you could see here, it's really easy to punch this into your calculator, but you have to be able to communicate with others in a scientific way. So a lot of times on a test question, people will get the number right and they'll lose points for screwing up this, or for getting the units, or like I did, for getting the minus sign, or for rounding in the wrong spot. To an engineer, where you round the number matters a lot. It can cost you more money if you add a bunch of sig figs, because somebody's like, well, that means I need to precision machine this instead of just getting the job done quickly. And that can add massive amounts to the cost. So it's important to communicate clearly. Sig figs, prefixes are part of that. Okay. I think we beat that to death. Now, just to go ahead.
Yeah. Well, when I was trying to finish this problem, I was trying to add both numbers.
Yep.
And my calculation, when I multiply the acceleration with the time, it gave me a scientific notation number.
Yeah, so your calculator might already be in scientific notation, or maybe it has a default. It's okay if it does that. And remember, you can change the mode manually. So one thing you got to get used to is figuring out how to change that mode on your calculator. Most calculators have some kind of mode button. We could talk about that more in office hours, and I could try and help you figure it out, or you can Google it. But the key is when you do an answer in this class, it's important to actually read the instructions, because I'll usually tell you a way to enter it. Now, if I don't specify the style, if I don't say engineering or scientific, then yeah. Now, the other thing is, if I could just scroll back, I skipped the first 13 problems, right? If you had trouble with this, there's a bunch of easier problems up here, more on SigFig, but notice if you go, I think, let's just go to page 1. Whoops. Page 1 tells you all about sig figs, gives you some examples. You could use the solutions. Page 2 is scientific, how to go back and forth both ways. Page 3 is engineering notation, how to go both ways with examples. Here's how to do the prefixes, et cetera, et cetera, et cetera. And then here's how to do math with sig figs. And I just want to point out, somebody asked earlier, why do I need to keep the extra digit? This shows you what happens when you keep the extra digit versus not. If you round every time, sometimes the final answer in this weird problem I just made up, it differed by 20%. Now, let's be honest. Most times it's not going to be off by 20%. But if you start rounding early in a problem, you could easily be off by 5%, and that could cost you points eventually. Certainly if you do it in a Canvas quiz. Right? So it's important to keep the extra digits. So that's why I say this is where I should round. That way, when I get to the end of the problem, I say, oh, okay, this was off in the hundredths column. This was off in the tenths. I keep the crappier column, that's the tenths, and then I round there. And so when you do this, that stuff works out. So there were some notes on, I don't know, let me just pause. That was a lot of stuff. So that's kind of a good warm up. Any questions about all of that? I'm just trying to get a view at
Professor George, is that kind of the what you would expect for a problem and to how we would write it out in the homework? Or?
Yeah. And you know, to be honest, I gave you the solutions, which is basically exactly how I would write it up. So each problem is going to be a little bit different. So what I was kind of hoping you would do is give it a shot on your own, fail, or get it right, who knows, then check the work and then fix your work using the solutions. Is that good, Dina?
Yeah, thank you.
Okay, cool. Yeah, because you're not going to get every problem right the first time, but if you try it on your own, then look at the answers, educational research has shown you learn a lot more that way than by just copying my work. So, but yeah, because it's very, I don't know how to do it other than say, yeah, each problem's unique. And that's why I wrote up every single problem for you. Cool. Other questions? All right, so we got about, about 35 minutes. So let's keep cruising along and then we'll take a break and then we'll come back and do the online activity. Let's look at this one. Let's look at 1.18 and let's do parts A and C. So while I'm erasing the board, you guys kind of look at that and I'll get warmed up, okay? So this is 1.18, I think. Is that what I said? 1.18, A and C. Let's do part A while it's on the screen share. Let's see if you remember. How many sig figs does this number have?
2.
2. Notice this is called a trailing zero. It's a trailing zero to the right of a decimal point, it's significant. These are leading zeros, not significant. Let's go over to this one. How many sig figs does this one over here have?
3.
3. These are trailing zeros, but they're to the left of the decimal point, not significant. So this one has 3. Good job. All right, so now let's convert A2 to meters and seconds. So I'm going to write that down. Now, let's be real here. If you wanted to convert that right now, what technique should you use?
Inches to
Nope.
Dimensional analysis.
Google. Right?
Nice.
Do you agree? However, there are going to be times in this class where you can't Google something. And so I need to show you the right way to do this. If I was going to convert this, I do this all the time. I just say, convert this number to this units, and it works all the time. So you could use that to check your work, but you need to know how to do this the right way. So, right, Google is your friend. You can use it. I'm just trying to keep it real, right? So now this is how you learn in a chemistry class. Sometimes what I do, just to see if you know the technique, is make up my own fake units like frogs and and just make up all kinds of weird stuff that doesn't exist on the internet, and then see if you could follow the pattern. So that's how I test you to see if you can actually do your stuff. All right. So somebody said this though. Somebody said feet to inches, right? So 1 foot equals 12 inches. And then 1 inch is 2.54 centimeters. And then 100 centimeters is 1 meter. Sometimes they call this the railroad tracks. Again, we see chemistry is actually useful. Okay. And then to go from hours, let's see here. I know that 1 hour is 3,600 seconds. Now, if you don't know all these right off the top of your head, I just want to point something out. On the back of the workbook, there's a lot of those numbers. Now, before we go on, I want to point out something here. Look at this one. This 2.54 centimeters is an inch. You might notice that there are no underlines on that, whereas this one does have an underline. Why? If we don't see an underline on a unit conversion, assume these have infinite sig figs. Okay, you could just say they have 20. That way they never affect the units or the sig figs of your calculations. This one is only good to 4 sig figs. Okay, that's all. So in this case, all of these have infinite sig figs. So if we started with 3 sig figs and all of these have infinite, we should end up with 3 sig figs as well. All right. Now, is this going to work out? Let me rephrase. Why is it not going to work out?
because it's squared.
It's squared. So that means I have to square both of these. Now, here's the only mistake people make. They forget to square both the number and the unit. You got to square both things, okay? So at this point, you could punch this in. You know where the answer is. Let's just go look at the answer here.
Wait, were we doing B or C?
Oh, whoops. That was part C, wasn't it? We could do both of them, but the main thing, so sorry if I screwed up there, but the main thing here is I just wanted you to watch out for squareds in your unit conversions. That was the goal of this. So I don't know who asked that question, but did that clear that up?
Yeah, no, sorry. I was just, yeah, no, I got it.
Yeah, I skipped part B just because I did part B in the earlier lecture. And so my thought is whenever possible, I'm going to try and do different problems in the early section and the late section. That way, if you want to get a different feel for the lecture, you can watch my other live stream and be bored out of your fucking mind. All right. So, all right. Yeah, that's enough on that. Okay. Oh, let's see. So where was that? Let's go look at the solution. Okay, so that you could see I try to put lots of words in here. So use the solution, people. I wrote them so you could succeed. All right, so you see the squared there. That was the part that caught people. There's weird little nuggets in here all over. Okay, so you could see, for example, engineers. Engineers often keep an extra sig fig if the first digit of a number is a 1. So an engineer, if they weren't doing the underbar, might write that whole thing anyways. More on that if we get to a later problem. Okay, let's keep going. Well, actually, I'm going really fast. It will kind of calm down after we get through some of this first week or two. Any questions while I've got you there? Just checking the screens here. All right, let's try. Let's look at problem 33 really quick. Oh, whoops, I want to go to this one. I think that, oh, wait, I want to do 28 next, I think. Sorry about that. 28, I forgot to write down 28. Okay, so let's look at 28. This sucker right here. So again, I'm going to label my screen. You can write your done. We'll catch up in a second. So 28. Whoops. 1.28. Looks like we have a, is it a circle or is it, it's a plate. Okay. We got a square hole cut in it. Okay, this distance here is d over 3. I'll show you my screen in a minute. If possible, avoid the diagonal fraction bar. Try to write your fractions with a horizontal fraction bar. That's good practice in this class. You'll see why. Okay. Almost there. Okay. And let me get back on speaker view. There we go. So you should see something that looks a little bit like this. Notice again, I'm just getting my work on my page, so it's easier for me to put the book to the side and actually focus on the problem. Okay, we've got this plate. It says the thickness of the plate is T. You might not know what that means, but basically it's thickness T into the page here, right? So while this isn't exactly the same thing, this would be like the plate and you could see the thickness. It's hard to see it, so they just say it's into the page or whatever. That's what I meant by the thickness of it. Okay. We were told the mass is M after the hole. And we're supposed to determine the density, G. We do not want to use the letter D for density because we're going to use the letter D for diameter, right? And so for us in physics, rho is the symbol. Rho, 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 your density, all the way down the stream. Okay, so rho, if you're not used to drawing Greek letters, I will show you. Here's how to do it. Start here at the curvy part, curve up and around, then down, up and around, then down. You may be saying, well, that's silly. Why don't I just write the letter P or something and just, I know what we have to do later. There's going to be problems where we have P, P, rho, V, V, all in the same problem, all of them. And so we need to know how to write all of these things. And so each thing means something. This is a capital P for pressure, lowercase p for momentum. This is a rho for density. This is V for velocity. This is V for volume. So I'm going to show you the symbols as we go along. You may say, well, I'll just write them however I want. I've tried to give you a self-consistent way of writing them so we can be less confused. T is another one. There's going to be T, T, double strike T, and taus. It's like, man, we got to keep all these letter T's straight. So it's important that you write correctly. So that means learning how to write Greek letters. Sorry about that. All right. Whew. That's the setup. How might we attack this problem? We're trying to figure out density. Does anybody know an equation for density? Anything?
M times
Rho
B.
equals M over B.
Density equals mass over volume, right? If you're not sure, you could look at the units. Typical densities are kilograms per meter cubed or grams per centimeter cubed. Okay, let's say we know this. How does that help us? We know the mass, got it. How do I get the volume?
Get the volume of the plate and then get the volume of the square and subtract them.
Okay, so we're going to do the volume of this minus the volume of the square. So what's the volume of this cylindrical plate without the hole?
R squared H.
Okay, and what's the volume of this square hole going to be?
D over 3 times H. No. 2D over 3 times H.
No.
Someone else do it.
Yeah, let's somebody else have a shot. How do I figure out the area of this square?
Length times width times height.
Yeah, length times width times height. So in this case, are you okay that it's side squared times the height because it's a side times side? And then, so what I'm doing here is we can then plug in, well, shit, I know this. That's just diameter over 2, right? And then Jake was trying to do it all in his head and talk out loud, and it gets confusing. So I think he knew what to do, but he couldn't say it correctly. And so this is where he meant. And then what is H in this problem?
Same thing.
It's the thickness T. In this problem, height is the, right, this dimension coming in or out of the page, which is the thickness.
Would you be able to scoot the board back a little bit?
My bad. Sorry. Yeah. Thanks for reminding me. If I ever do that, just give out a shout. All right. And so from there, we're off to the races. Now you could group these up. Yeah, exactly. It's very difficult to just say it out loud without writing it down. A lot of times I will, you may hear me say this later on. I let the paper do the work. By that, I mean, most of us can get it right when we write it down on paper, but we screw it up when we try to do it in our heads. And as these problems get crazier and crazier, it gets out of control. Let me, just in the interest of time, I'm going to show you the solutions here. You could try and beat me to it while I'm scrolling. Here it is. And so the strategy you had was pretty good. First, we get the volume. We write it like this, and then we put in the stuff that's specific to our problem. So these are general formulas up here, pi r squared and L width height. Those are kind of general formulas, right? Then we plug in the specifics for our problem. We do the math, then we group this stuff. In a math class, you might think, leave it like this. I argue this is a lot better for an engineer or a physicist because it's practical. It's just easier for us to get a feeling, right? You could punch these things in. If you tell me what D and T are, I punch in the numbers in a calculator, I got the numbers really fast. So that's a better way to go for most engineering. So you've got to get out of this habit of being a math purist. Now, don't get me wrong. I love math. I got a math degree. I've taught math at the community college level. I love math. But this is a physics and engineering course. This is just a prettier way to write it for that. Now, finishing this out, how do you get from that to the density? This was not the answer. This was just the volume. So now we know we use the mass of the plate over the volume of the plate. We plug that stuff in. This is not good enough. It is considered bad form to leave that decimal number down here. To get it out, I factor it out and then just punch it in. Okay, so yeah, if Shadrach likes the other way, that's cool. There will be times in a 163 class where we do want that pretty form. But for practical engineering, a lot of times this is a better way to do. Oh, crap. Sorry. Let me get rid of my annotations there. Now, just to show you why you should read the solutions, notice something. All day long, we've been doing units. This problem doesn't have units. Why? If you plug in numbers, the numbers have the units. And so when you plug in this stuff into there, the units will be in the problem, and the final answer will have units when it's in numerical form. All right. All right. I don't like to do this a lot, but I just know that today's group activity killed everybody in the earlier section, so I'm trying to hurry slightly. This is a good time to ask questions about this, right? If you are looking at these solutions and they don't make sense, you could say, I don't know how you got from here to here. You could take a screenshot and say, dude, what did you do? And I can either add it to the solutions or just tell you via email or something. All right. So it's right. The solutions are pretty thorough, but not perfect. It's up to you to find the spots you don't understand. And I want to help you understand them, but I just don't know what doesn't work for you. Okay.
So are you just basically manipulating like the variables?
Yes.
They're
Yes.
just kind of like rewriting them?
Yeah, I'm just moving them around and doing algebra. It's just algebra.
Okay.
Yep. And then what I am doing in addition is that extra step of plugging in the numerical factors in the parentheses in. But other than that, it's just algebra. Normally I would work that all out on the board, but like I said, I'm trying to hurry through for reasons we discussed. Good question though. Other questions? All right. I'm going to keep going. I know I may be hurrying and you could interrupt me at any time. Anytime, interrupt me. Now I want to look at 33, I think. Oh, this was a fun one I did. This was an old test question. It's pretty cool. All right. Now I want to talk about this dimensional analysis stuff. Okay. So this is called dimensional analysis. If you have your workbook, you might note I put this little thing here. This is the thing about Vince Tobin's handout or whatever. I said that earlier, the dimensional analysis handout. It's really, really good. It follows exactly my style. It shows you how to do things in this style or that style, where you use the units or when you use these goofy L's and T's, okay? One of the main things I want to point out is that M and the units of M are not the same. Furthermore, the units of X are M, but it's a different M. It's not italicized. So we have to be very careful here. Let me make up a new problem for you and just show you what I mean. Okay. Speaker view. And then don't forget, we are going to get a break before that. So if you're sweating and dying here, the break is coming soon. Hang in there. Okay. I'm just going to make up a problem right now. Let's say D equals S. Wait, how about let's do K A V over T minus B over V X. All right, let's say we had some weird equation like this. Now, typically in physics, we know that the units of, that's what this means. Sometimes people say the dimensions of. Okay, so it's either the units of, we usually say the dimensions of A. That's an acceleration. So this would be meters per second squared. Now notice what I'm writing here. This is not A. This is the units of A. That's why I don't have a number here. It's just the units, okay? So A would have to be a number plus the units. This is just the units of it. This would mean the units of V, that's typically a velocity, that would be in meters per second. The units of time, those are usually seconds. Now you might be saying, well, wait, what about milliseconds or microseconds? Those are all seconds, because think the number could include the powers of 10. So like, what if you're saying, shouldn't it be millimeters or feet or whatever? Yeah, whatever. You could convert all those. Any velocity could be converted to meters per second. Any acceleration could be converted to meters per second squared, etc. And then X, usually that's a distance in meters. D, for us, it's not density. That's usually a distance. So that's probably in meters. So let's say we knew this information. We know the units of these terms. And let's say I ask you to determine the dimensions appropriate for K. Or said another way, maybe I say, what are the units for K? Before we jump in, like a lot of people, what I usually see people do when they first start is they start doing algebra and they solve this crap for K. We do not want to do that. There's a step you could do first, which makes your life a lot easier. Take a look here. You guys probably have heard the phrase, you could only add apples to apples and oranges to oranges. It applies in this scenario here. Let's say we know this thing has to be in units of meters. Whoops, let me get this closer. We know this has to be in units of meters, right? That means this whole blob has to have units of meters. And that means this whole blob has to have units of meters. Oh, and sorry. Oh, Myung-hoon, this is just a random problem I made up. I'm just making one up. It's similar to the problems like 33 and 38. I just yep, good question. Sorry about that. Made up problem. Okay, but so this is the step that a lot of students forget. It's basically apples plus apples equals apples. That means I could skip a bunch of algebra by doing this. I could tell you the units of this have to match the units of that. The units of D have to equal the units of K times the units of A times the units of V divided by the units of T. Now, to be clear, D does not equal this. D does not equal this. It equals this minus that. But the units of D, that's what this sentence means. The units of D equal the units of the first term. Now I do my algebra and flip stuff around. Solving this for the units of K, this trick is used all the time in physics. If you're thinking this is stupid, just be aware we use this all the time to find problems, okay? It really is a useful trick. So it's going to be the units of D times the units of T, all this divided by A and V, I think. And I should be careful, the units of A and the units of V. So again, I multiply by this, divide by those, flip the sides. Okay. Now, in this case, now I plug in what all these different things are. So now I'm running out of room. I got to lower this down a bit. The units of K, I hope that you are going to see the merits of the horizontal fraction bar that I was whining about earlier. Okay, so right down here, it's going to be D, which is in meters, T, which is in seconds, divided by, what is that, meters per second squared, times meters per second. Obviously, if you squared one of these things, you would also square the units. We saw that earlier. But now it's a lot easier to keep track of this stuff. We could clearly cancel some stuff. What I'm going to do is multiply by seconds over meters and seconds squared over meters. And I got to do that to the top and the bottom. So by using the horizontal fraction bar, it gets less confusing. As the problems get bigger and bigger and bigger, these things can become a nightmare. And it's really hard. Like sometimes there's multiple steps involved. And then the diagonal fraction bar can suddenly end up looking like a 1, and you get a problem wrong and you cry and you have to retake my class and you have to see me even more. That's not what we want. We want you to pass, get a job, and make fun of me. Okay, seconds drop out, meters drop out, second squares drop out, meters drop out. Now on top, one of the meters drops. I get seconds to the, 1, 2, 3, 4 over meters. Okay. So does everybody agree that K is seconds to the 4th per meter? Let me repeat. I just said K is seconds to the 4th per meter.
The units of
No, the
Exactly. The units of K are seconds to the 4th per meter. I was trying to screw with you, but you caught it. Good. So remember, there's a big difference between the units of K being this and K. K is going to be some number, but the units of K will be this. That can help you check your work later. All right. Okay, 8 minutes. 8 minutes. What do we got? Let me see. Oh my gosh, I think we're ahead of schedule. Oh my gosh, I was going so fast. All right. So, any questions right now? Sorry, I was going so fast. I could have gone about whatever 3% slower.
The BX in that last question, why do we just ignore that?
Ah, yeah, good question. So let
I
me
was
get
just about to ask that.
Yeah. So the idea here, yeah, I did that so quickly. And what happens a lot of times, you guys are writing when I'm talking. So don't be shy about asking questions. I actually really want to answer them. Okay, that's my job. So take a look here. We were saying earlier that was the apples plus apples equals apples statement. So if we're talking about the units of things, we know that this has to be in meters and meters because this is in meters. So what that does is it allows me to ignore this term if I'm looking at units only. This is not valid if I'm trying to solve with numbers in there. It's only valid for this funky unit math. I hope that's addressing it. But so the idea is the units of this have to match the units of either term. That's why I wrote the units of this match the units of just the first term. Did that help?
So it's because BX does not have its own units.
It does. Bx over v. See, we could actually redo this entire problem again, but do the units of this equal the units of that. And so this whole blob, when you get, okay, so imagine someday somebody gives you a table of numbers that you're going to plug in. You know that when you plug in all these numbers in here, you'd better end up with units of meters. Everything else should cancel. Similarly, when you plug in the numbers for all these symbols, you'd better end up with units of meters. Why? Because I know this side is in units of meters, and they all have to match. I can only do apples to apples and oranges to oranges. Did that help a little bit or no?
I think it did.
Let me show you. Let's check. So let's say we redid this again. Oops. This is A. So we still have all these things. So these, again, are not the numbers. These are just the units that should be associated with those numbers. So let's say we wanted to do this again. And I want to figure out the units of B. The units of D should match the units of this or the units of this. The minus sign doesn't matter. Minus signs don't change the units. So I could write this and use this to figure out the units of B. And this is totally weird to most students when you first see it. It's super weird. And then I could plug in, this is meters. times, whoops, sorry. This is units in meters. This is meters per second. Whoops, meters per second, not meters per second squared. This is meters. So B has to have units of velocity. That's weird. Whatever. Is that helping a little bit? Seeing the second example?
Yes, thank you.
Right on. Now, if you're wondering, obviously me showing you this in one video clip does not get the job done. So problems, let me show you where these problems are in the workbook. They kind of start right around here, page 13. Now, look at this first one. I said, basically, don't try to do this on your own. Use the solutions for 1.33 and then just kind of follow along. That's kind of your worked example. And then this shows you in a lab, maybe you take these measurements and this is what they might look like, right? All these different measurements. And so you could use these are real, well, some of these are real physics equations, not this one, but you could use these to try and figure out the units. And furthermore, these are, if you're a little worried, try these problems, 1.36 through 1.38. And some of those, I forget which ones. Hold on. Whoa. Sorry about that. I didn't have time to hit the mute. I had to sneeze. Thanks. You could practice this again with these questions right here and see how you do. And this one, this will see if you really know what you're doing, 1.38. So there's some extra practice problems. And like I said, just going back one more, this stuff is not in your textbook at all. Oh, come on. I don't want that one. Got my live stream. That's so meta. All right. Where was this one? Well, I know it's right here. So in the chapter 1 solutions are right here. This has a handout he made. And I just want to show you this. Whoa. He walks you through this in a way that your textbook does not. And he does lots of worked examples. He does all this kind of stuff. He shows you some of the same things I was just saying, talks about all this stuff. And he shows you the rules and gives examples. And yeah, I think it shows you, it walks you through eventually. Oh my gosh, he's very detailed. Yeah, so this, okay, so let's just call that good. You could read that on your own. Yeah, so definitely check this one out. I think, where is that? Somewhere in here. Yeah, and here he gives you a hard example and he shows you how it works out. Sometimes you could do square roots in there and all these kinds of things. This is the one we were just doing, basically where you have something equals 2 different terms. So it's all in there and none of it is in your textbook. Why? I have no idea. Students have so much trouble with this. So definitely read that handout.
And,
All
and
right.
this would then help us make sure that we're using the correct units when we're answering a question, right?
Yeah. What will really happen is as the semester goes on, we're going to write something down and we don't know if it's right. And so to check if you're right, one thing you can do is say, well, do the units match on each side? So quickly you check the units of this and check the units of that. If they don't match, you know you screwed up your algebra somewhere. If they do match, you might be correct. You don't know it, but usually you are. If you get the units right after a long algebra problem, usually you got it right. Not always, but you could get unfortunate and like accidentally have 2 cancellations by accident. Is that good?
Yes, thank you.
Right on. All right. 5:55, my favorite time to take a break. So let's take a break. Now, before we do this, I want to say a couple of things. When we come back, I want you to just leave your Zoom open if possible. I'm going to assign you breakout rooms. And so just to give you a clue how the group activity is going to work, if your ad code hasn't worked yet, I understand that. Just kind of deal with it and I'll put in the grades manually somehow tomorrow in lab. So just join your group. But let me show you where the group activity is. Come on, you slow computer. Okay, in week 1. So let me just go through this stuff. When we come back, we're doing a group activity. Basically, here's some things you should think about. We want to be positive, not negative. So try to talk to each other and consider each other's thoughts and don't be just a jerk. Okay, that's one thing. Next, Yeah, dominating. That's me. That's my job, right? Rambling. I also take care of that. Okay, so yeah, clearly these are not good. We try to do these behaviors. Great. Let's go back. You should be able to, hopefully at least one person in your group will be able to log into Canvas and look at this. So now your goal is to make a file of one of these types and upload it. What are you supposed to work on? Oh no, did I forget the, okay, I'll do this when we're on the break. I forgot to upload the file. So I'll get the file uploaded in just a second. Now that said, one thing that may help you is the following. You're trying to work together. It's okay if one person does all the writing as the secretary, and then you guys work together. What's really difficult in the online environment is to show people what you're writing. Some of you have tablets and it's really easy to write on the screen. Most of us do not. So one thing you could do is after I make the breakout rooms, if you have a phone, you could also join the Zoom through your phone and then put the phone on a stack of books and point it down at your paper, and that camera will show people what you're writing. And that way you don't all have to do it. And what I would really like is to rotate who gets stuck being the secretary each week, so that, the secretary basically is just trying to get down what everybody's saying and work together. Now I want you to make this work, because if you don't, I got to replace it with a bunch of hard quizzes. So anything you can do to figure this out would be awesome. But if it's really failing and if it's really hard to figure out, I could just replace all the group activities with quizzes on Canvas, which, to be honest, it's a lot less anxiety for students because you know exactly what to expect, but it's also a lot more anxiety. So it's both. Okay. I'm going to make the breakout rooms now, and then anybody that wants to, you can then join with your phone as well. So I've created the rooms. I'm going to open them. Now, just keep your Zoom open and just join those after the break. So take a break, come back at 6:05, go straight to your breakout rooms, and I'll circle around and help you. Okay, I'm going to get that file up. Go ahead and take your break.